In this video, we talk about Section 8.2 Applications to Geometry. In Section 8.1, we calculated the volumes using slicing and definite integrals. In this section, we use the same method to calculate the volumes of more complicated regions as well as the length of a curve. So first, we learn how to calculate the volume of a revolution. So we look at the first example. The region bounded by the curve y is e to negative x, and the x-axis between x is 0 and x is 1 is revolved around the x-axis. Find the volume of this solid of revolution. So we first sketch the graph of this function. Y is e to negative x. Between x is 0 and x is 1. When x is 0, it's 1. Suppose this is the graph of this function. Y is e to negative x on the interval from 0 to 1. Now we rotate the graph of this function about the x-axis. The curve sweeps out a solid with circular cross-sections. This is called a solid of revolution. So now we wanted to find the volume of this solid of revolution. So we start by slicing the region perpendicular to the x-axis. Slice the region perpendicular to the x-axis, giving a circular disk of thickness delta x. So from here to here, so this is delta x. And the radius of this disk, this is the radius. The radius is y. Radius is equal to y. So y is e to negative x. So the volume of this slice can be approximated by the area of this circular disk with thickness delta x. So the volume is equal to the area of the base times the height. So it's pi y squared delta x. We know y is e to negative x. So this is pi e to negative x, then square delta x. The total volume of this solid of revolution is equal to the sum of all the volume of slice. Total volume is sum those together. So as the thickness of each slice tends to 0, so we get the total volume is equal to the definite integral 0 to 1. This is pi e to negative x squared dx. So limit of integration is the values for the variable x. So how x is from 0 to 1. So this is equal to pi constant, take it out, pi integral 0 to 1 e to negative 2x dx. So this is pi negative 1/2 e to negative 2x as from 0 to 1. So x is 1. So pi negative 1/2 e to negative 2 minus x is 0, pi negative 1/2. So this is negative pi over 2 e to negative 2 plus pi over 2. So this is pi over 2. The inside is 1 minus e to negative 2. This is approximately equal to 1.36. So the volume of this solid of revolution is equal to this number. So this is about how to calculate the volume of a revolution. So next we look at the how to calculate the arc length of the curve y is fx. So the formula is for a less than b, the arc length of the curve y is fx from axis A to axis B is given by arc length is equal to the integral from A to B square root 1 plus f prime x squared dx. This is the arc length formula. So now we look at the second example. So find the length of the curve fx is 2/3 x to the power 3/2. Then x is from 0 to 1. So for this example, we use the arc length formula directly. So to use this formula, we need its derivative f prime x. So this is 3 times 3/2 x to 3/2 minus 1. So this is x 1/2. So we get the arc length by the formula. This is equal to integral s from 0 to 1 square root 1 plus f prime x squared dx. So this is the integral from 0 to 1 square root 1 plus x 1/2 squared dx. So this is integral 0 to 1 square root 1 plus x dx. So the antiderivative of this function is 2/3 1 plus x 3/2 as from 0 to 1. So when x is 1, the 2/3. 3/2 x0 minus 1. So the arc length is equal to this one.